Okay, maybe we should just start. So I was just going to start by giving a background as to how these training sessions came about. Basically, Larry, who's also here on the call, we both instructors at Canal, and in particular, Larry had started a more automated way of grading students' Fieldworks databases. And we thought that having a Flex tool might actually give us even more data from those databases. So I asked Craig if he would help us learn how to write modules to interrogate the databases. And Craig in turn said that there were aspects of the Flex data model that he wasn't so clear about. So then I asked Ken if he would help us to understand more about that. And initially it was just going to be Larry and I getting the training, but then we realized actually it could be useful for many more people. And so here we are, all online together today, and hopefully going to learn lots. So that's basically how it all came about. And Craig, if you could just say your little introduction, that'd be great. And then we'll pass over to Ken. Thanks.
Great, thanks, Sarah. Yeah, thanks so much for organizing this. I've been with SIL for about 20 years, and right now we're based in Vanuatu, so enjoying the Pacific Islands. FLExTools came about many years ago when we were in need, colleagues were in need of a way to sort their Fieldworks databases in ways that Fieldworks couldn't handle. Someone in our group had written some Python code to do the grunt work, the things that needed to be done, but we needed a way to integrate that with Fieldworks. And so I took on that project. My background is in software development and turned linguist. And I decided that rather than just writing a specific tool for that custom tool, I could make something more generic, something that could serve a wider purpose. And so FLExTools was born, designed so that anyone with a little bit of code can write some code to analyze, to read the Fieldworks database, to analyze the data, to export it, and even modify it and make corrections and fixes and cleanups and so on. So yeah, that's where FLExTools came from. In this workshop, we've got 3 sessions after Ken to look at FLExTools itself. First session, we'll probably just look mainly at reading data, how we can get data out of Fieldworks. Second session, get into some writing, changing, a bit more detail. And I'm hoping that most of you are keen to write your own modules. So for the third session, I'm keen to see you guys writing and working on stuff, and hopefully we can interact offline a bit, and in the third session work through any of the challenges and stumbling blocks and things that you've come up with and see if we can work through some of those. So really hope this can be useful for everybody. I've done about 3 workshops in person. This is the first time trying to do this online, so we'll see how it goes. Thanks for joining.
Okay, I guess I'm supposed to give a brief background on mine. We joined Wycliffe, my wife and I, 52 years ago. And the first 22 years we were in the Philippines or assigned to the Philippines. I started out as a radio technician, and after 4 years, we ended up getting some data point computers. And I started learning both the hardware and the software end of things. And for the rest of the time, I developed the computer department in the Philippines, wrote a number of applications, helped users use various things and helped them through problems and stuff that they had. Then in 1994, I ended up getting a master's in linguistics from the University of Colorado in Boulder. And after that, we moved to Dallas, and I helped develop the LinguaLink software. Larry was back there helping then too. And supported LinguaLink's users for quite a few years. And then when we switched over to Fieldworks, I started doing some development in Fieldworks, but mainly I've been supporting users and developers in various ways throughout most of that time. So that's my background. And so I think now I will switch over and see if we can get the thing going.
Just while Ken shares his screen, he's asked that, for questions to be at the end, but if you, I think you might forget your questions as you go along, feel free to put them in the chat, but Ken will look at them, questions at the end, just to let you know. Thanks.
Okay, so this session here is the basic concepts of Fieldworks, how's the data stored, and the various pieces, but not how to put all the stuff together yet. And then on Thursday, I'll be going through the lexicon model and some grammar of how we put the various pieces together to work in the lexicon. And then next Tuesday, I expect to cover some more of the grammar and interlinear and notebook models. So there's a lot of material to cover, and unless you do a whole lot better than I do, you won't be able to get it all together in 3 sessions. But I do have all of this in a document that you can download from software.sal.org/fieldworks/support/technical documents. And if you look for the Flex 9.1 conceptual model PDF, that's it. So you can go back there and review anything. And also I'll have links in that document to a test project as well as the PowerPoints. So first of all, what is a Fieldworks project? Well, it's a folder that's typically in C program data SIL Fieldworks projects. The main part of the project is a single file called an FW data file. It's an XML file, and it has to match the name of the folder to be able to open it up. Then there's a writing system store directory that holds XML LDML files for each writing system used in the project. There's a configuration settings directory that stores various XML files containing user settings for field visibility, sizing of windows, columns, filters, dictionary configuration, etc. There's a linked files directory for storing pictures and media files. There's a shared settings directory that holds some user settings for writing system fonts, keyboards, language name, and abbreviation. And then there's a temp directory that's used for some caches for speeding up sorting and some things. In addition to the directory, there's several settings files that are stored under local app data SIL. In the registry, we have under software SIL Fieldworks in both HKey local machine and HKey current user some settings, and then there are a few Windows environment variables that are also involved. So that's basically what we have. So the Fieldworks XML FW data file is pretty simple as far as the basic structure. It's a language project element, and it has a version number. And when that version number increases, we provide a migration path for older data to come up to that version. And then once the data is migrated, it can no longer be opened in any of the older versions of Flex. And we haven't had a migration for a number of years now. We try to avoid it as much as we can, but we might do it again some point. Then there's optional custom fields. And then the rest of the file is all RT classes. And there's an RT class for every instance of every class that's used in the project. And one thing to be aware of, sometimes there are some classes that don't have any actual data. So they just have the beginning element and no data. So you need to be careful for that if you're not using XML type, XML aware processes. And if you're ever going to modify the FW data file, you better make a change, backup first, because if anything goes wrong, you may not be able to open Flex again. In Flex, there's a tools, utilities, write everything. That is a good way of cleaning up the data, the FW data file. It writes everything out in a standard format so that fixes up some problems that can occur. All data is stored in Unicode. Flex support for Unicode is excellent. I'm not sure of any other program that does better than Flex at following the guidelines where you're supposed to be able to work regardless of the normalization and have searching and other things work seamlessly. And we do pretty good at that. The way we do that is when we read things into memory is we normalize all the data to NFD. That means like an A with a Grav accent is 2 characters, an A and then a Grav accent. So when you do bulk edit or keyman keyboards that use context or FLExTools, you need to be aware that the data you're getting is NFD data, and you want to try to write the same thing back out again. Data outside of memory is NFC. So anytime Flex saves data, including the FW data file, it uses normalization NFC. So now the A Grav has a single character instead of 2. And data is switched to NFC for saving to FW data, clipboard, exports, basically everything we write out except internal things like FLExTools and bulk edit. We switch to NFC, and then whenever we read in the data from FW data, or if people are typing or pasting in or imports, we change all of that to NFD as it comes in. And if you're not aware of this Unibook program, it's a great free tool that lets you see all the characters in Unicode, and it shows the normalization and the UTF-8 settings and various other information. You can also copy a character and paste it into any place using that program. Data in Flex is all object-oriented. All data is stored in using classes. Each class has a class ID or CLID often for abbreviation. Classes have properties with a field ID or a FLID that stores data. Classes are hierarchical, starting with CM object, and each subclass inherits properties from all superclasses. Information that occurs more than once in an object requires additional objects that can be repeated, resulting in an ownership hierarchy. And there are abstract classes that cannot occur in data, but their subclasses can. So this is just a real simple object-oriented type view of a dictionary where we have lex entries and has a lexeme form, citation form, pronunciation, and then that owns one or more lex senses that has a part of speech, gloss, definition, and various notes, and that can own one or more example sentences that'll have the example sentence and a translation. So this is not the Flex model. I mean, we do a lot more than that, but that gives you a brief overview. So writing systems are all very important. Almost every string or substring in Flex is tagged with a writing system that identifies the data in that string. Writing systems define language, script, region, collation, font, keyboard, how to display dates, time, localized language and country names, and many other things that Flex ignores, but we pass it on. Writing system tagging and data structure is stored in locale data markup LDML files as defined in Unicode technical standard number 35. And we enforce that in Flex. And just to see some samples in Arabic, we would, the Arabic and Arabic script, we would tag with AR. An Arabic and a Romanized script, we would have AR-LATN. If it's Arabic in International Phonetic Alphabet, it would be AR Fon IPA. And if it's an audio recording of Arabic, we would have AR-ZXXX audio. And anything after the X tag is user defined, and SIL basically has the user defined that part to be an audio file that can be a recording of the string. WS Tech works with, that's writing system technologies, works with the Unicode Consortium to help bring new languages and information into the standard. WS Tech maintains a web API to provide writing system information. You can see the URL there. And if you use that one right there, it will return an English LDML file with some specialized SIL information on fonts, keyboards, etc. And WS Tech maintains a list of valid writing system codes that Flex uses and stores in the SLDR cache under C program data SIL. And there's a file in there called langtags.json that contains all the different writing systems that are available basically and gives you information on each of those. The LDML identity element has one or more of these 4 elements: the language code like EN, and then a script type, which is like LATN, region type like US, and variant type can be X-SCI to stand for something. And each language tag has a default script and region. So EN, EN Latin, and EN US are considered the same thing and normally use EN as the writing system tag. Flex will not allow an EN and EN-Latin to be used separately in a project. The writing system tag in a FWData string property corresponds to the LDML file name, except in rare migrations from older systems where it then uses the internal identity, so that en-latin.ldml actually has en inside, and it'll work okay until you try to modify the writing system, and then you have to resolve the problem before it'll let you move on. Each project has a writing system store directory that stores all writing systems used in the project. There's a global writing system folder at C program data SIL writing system repository -3. And when a user adds a new writing system to a project, if it's present in the global store, it will copy that writing system to the project writing system store directory. If not, and it's in the global store, if it's not in the global store and the internet is available, we will request that writing system from the API, and we'll store this in C program data SLDR cache and in the global store in addition to the local project. And then if a writing system is modified in Flex, the project LDML file is modified and then copied to the global store. Flex maintains 2 lists of writing systems for use in a project. We have vernacular writing systems, which would include lexeme form, example sentences, interlinear text. And these are all in vernacular language. There should only be one vernacular language, but it can have any number of writing systems for that language. And you get to those with formats set up vernacular writing systems. Then there are analysis languages for glosses, definitions, and other languages describing the vernacular language, and these are stored under analysis languages. You can have any number of analysis languages, with each one can have any number of writing systems. And these are accessed and modified in format setup analysis writing systems. And when you hide a writing system, the data remains in the FWData file, but it is not displayed, and you can unhide a writing system to show it later on. If you delete a writing system, it deletes the data in FWData and deletes the LDML file, so it's gone at that point. In FWData, there are 5 lists of active writing systems. Writing systems listed in the writing system properties dialog are stored as space delimited list for vernacular and analysis and are available for use. So that's under Vern WSS, and analysis WSS has the list. Those are the ones that will show up in the dialog. Ones that are checked in the writing system dialog are stored in a different set of elements. These normally show up on each property that supports multiple writing systems. They are defined for vernacular, analysis, and pronunciation, and they are always a subset of the full list. The shared settings folder in a project has a PLSX file that is shared in send receive and one or more ULSX files that are not shared in SR. This means that each user can have a different font and keyboard for a writing system, but it also means that each user must make sure each writing system font and keyboard is set properly when they get a project from colleague or after a project reset. Also, these fonts can be overwritten by styles. The PLSX file stores language name, abbreviation, and spell checking IDs. So that's in a writing system element with abbreviation, language name, and spelling ID. And that is shared with all users. But then the USLSX file, that's a user file. Each user has one. It stores the font and keyboard associated with each writing system. Basic properties, strings. All strings in Fieldworks store Unicode data. In the FW data file, it is stored in NFC normalization. There are two basic types of strings which are poorly named since all strings are really in Unicode. But way back when, we called the one Unicode, and what that means, it's a sequence of Unicode characters which does not allow any embedding. And in the Flex UI, the writing system and style combo boxes are disabled when you're in one of these fields. And then there's a string field. That's a sequence of Unicode characters that can have embedded substrings with styles and different writing systems, plus some other specialized attributes. In the Flex UI, the writing system and style combo boxes are enabled in the toolbar. The Fieldworks 6 SQL version also had big varieties, but in Fieldworks 7 and later, that disappeared when we went to XML data, so big is no longer used. Both types of strings in Fieldworks should never have a carriage return or tab. Flex tries to prevent this on import, typing, pasting, etc. Occasionally something slips through. In this case, when the field is displayed, all the text following the CRLF or tab will not show. And if you place your cursor at the end of what appears to be the end of the string and press delete, it will delete the CRLF or tab, and then you'll see the rest of the string. So if you're modifying data, make sure you don't put any carriage returns or tabs inside the Flex data. The Flex string, I should say. Flex can force a line break in either type of string. In the UI, this happens when you enter Shift-Enter. This inserts a U2028 line separator character in the string. And this is somewhat similar to having a new paragraph in a string, but it's still a single string and you can't have paragraph type formatting on it. Both types of strings can be used by itself in a property, or a property can hold multiple sets of equivalent strings in different languages or writing systems. So these are called multi-Unicode and multi-string. The multiple property always has a writing system associated with each alternative string. And in a multiple property, every string in the property must have a unique writing system. The strings in a multiple property are normally the same string written in a different language or a writing system, or any combination of these. So Unicode strings are just a sequence of characters with no formatting. In the file, we have the property name and then a uni element that holds the characters. And this is the name property in ST style. The string is in a single uni element. Flex needs to use a font from a writing system when displaying data, and uses an open box for characters without a glyph in the font. The dictionary view is a browser view that substitutes glyphs as needed. So in data entry and interlinear in places that are not using a browser view, you might see a square box, which means that that font that you're using doesn't have a glyph for that character. And as in any XML file, some characters must be use character identities to avoid messing up the XML. For a string property is represented with a stir element containing one or more run elements, each with a specified writing system. So all characters in a run share the same attributes. Whenever a set of attributes change, it requires a new run. So the following shows the contents of a sttext para object with a single run in English. So we have the str element, and then we have a run inside of that with an English writing system and then the actual data. The following shows the contents of a sttext para that includes multiple runs with changes of writing system and styles. And the content below shows the text that says some English with emphasized in bold text, and then French, Francais, and Francais in IPA. So to do this, we have one stir element, and then we have a bunch of run elements inside. And then each run has a writing system and an optional style. So the first one is English, that has the English part of the string. And then for the emphasized one that we want to have italics, we use a name style called emphasized text. Then we go back to just plain English again for the and. Then we have a strong style to get the bold part. And then we go back to English again for some more text. And then for French, we switch the writing system to French, and then back again to English, and then French IPA, and then back to English again. And throughout the things that I show, the yellow part tries to show where all of the pieces are for a given string. A run can only have one named style element. If you want strong emphasized, you would need to have a single style that combines both features. The following shows the contents of a paragraph with a link to an external file named x.html. Relative paths start in the project linked files folder. So in this case, we have a stir element that has a run that says this is a link to a file, and then we have a run with an external link attribute that gives others, it's a relative path, others \x.html. And it also has a named style to hyperlink, just so it shows it in test, it'll be look like a link. And so if you click on that link, Flex will send this file to the operating system and say display it in whatever program you normally use for that. And then since it's a relative path here, it would actually be located in the project linked files setting or directory. Then the following is a hyperlink to a lexical entry in the current project, but it could be to a different project. The link URL includes the project name, tool, and object GUID. So here we have another plain stir, but we have a run that gives the text. And then we have an external link element again, but now we have a URL instead of just a file name. And when Flex gets installed, it provides a handler for handling SILFW in the URL. And so then it has the database name and the ID, the GUID of the element that it wants to display. And if you click on that element, if the current project is open, it'll jump to the whatever GUID that you have in the element. If the GUID or if it's a different database that's not open, it'll open up the database and jump to that link. You can also paste this URL into a browser or a Word document or other places, and when you click on it, it should open Flex and jump to that entry. So these links can be added. Okay, I already said that. Many properties or fields in Fieldworks are designed to hold strings that will never have embedding, but may have translations in different languages or writing systems, like Lexeme, Gloss, and names and abbreviations for list items. Here's how these multi-Unicode properties are stored in Flex. So we have the name, and this actually is a name for a CM possibility object, but then we have an English AUNI element that holds the English string, and then we have a French AUNI that holds the French, and then we have a Spanish one for here. And so that's the way those are stored. And again, you cannot have two AUNIs with a WSEN. That'll cause Flex to grumble and crash. This, okay, I already said that. In this case, okay, each Fieldworks Unicode string is stored in an AUNI element, and the writing system is indicated by the required WS attribute of the AUNI element. And writing systems in a multi-Unicode AUNI element must be unique, and you cannot have any embedding in these because they're Unicode instead of string. Other properties or fields need the ability to store equivalent translations, but also need to allow embedded writing systems and formatting, like definitions, example sentence, example translations, all note fields, and various other ones. So here's how this would be stored in a multi-string property. So this would be a translation property on CM translation. And here we have two different strings. The strings are both each alternative has an aster element, and then the aster has one or more strings, run strings inside. And so we have an English one here with English, and then we have a French one with the French translation. And again, you can't have in one property, you can't have two aster elements that have the same EN writing system. Okay, writing system must be unique. Okay, I've said all that. We have binary properties that there's only one in the model at the moment, which is a SID property on user config account. And this is the way the binary is stored. Our current model doesn't even use this, so I'm not quite sure exactly how that works anymore. But then Boolean properties are represented with a property name and then a value of true or false. And the default value, if it's missing, is false. We have a GenDate property that provides a way to store an approximate date without a time. For example, before March 1200 AD, they are stored as an int, 4-byte int. This is a decimal representation of a generic date without a time, and it's up to the software to make sure that the int is a valid date. The range is from 21474 BC through 21474 AD, and the format is digits here. First 4 digits is the year, and if it has a minus, then it's BC, and if it's all 0, then it's unknown. Then there's a 2-digit month. It's for BC, it's 13 minus the month, and 0 is unknown. If it then 2-digit day, and if it's BC, it's 32 minus D, and 0 is unknown. And then the final digit is one of the following. It's 0 if it's before, it's 1 if it's exact, it's 2 if it's approximate, and 3 after. And a gen date that has 0 altogether means there's nothing entered in it. Gen date properties are represented as an element with a value. Basically, it's the date as you read it. And so you can see it, read it pretty well. And this is the date of event property on R and generic rec, representing before April 2, 2024. The generic date is stored as a decimal number. Okay, I already said that. Gen date is also available on CM-Person for date of birth and date of death, but it's not implemented in the current Flex UI. Then we have a GUID property. It's a global unique identifier, and it's stored in a val element or attribute, and it's in this format. It's all hex digits. This is the list version property on CM possibility list. The GUID value is stored in the val. We also have HVOs that are internal to Flex. And often our code refers to HVOs, that stands for handle to a viewable object. And it's a single integer that is assigned to each object when it's loaded. And while in memory, it's a reliable and quick way to find and reference objects. However, the next time the project is loaded, especially if objects were added or deleted, some or all of the HVOs could be different. And in debugging, it's often challenging to find a GUID for an object when all you have is the HVO, and FW data only has GUIDs. The HVOs are not stored anywhere. And GUIDs never change, but HVOs can change, but not when you're in one run of the project. Integer properties hold positive or negative 64-bit integers and are represented as follows. And the homograph number is an example, and it has a val that equals the integer string. And this is the homograph number property on FLExEntry. The default, if it's missing, is 0. There's a text prop binary. That's a binary data that represents text properties. They are used in rules and style rules and ST style. In the FW data file, they are stored in a prop element with label and value pairs. So we have a prop for bullet numbering scheme that equals 10, and a bullet numbering start at 1, and a first indent of minus 9,000. And then a leading indent of 2100. So that would be one rule. Then you can have a named style rule that gives the name of a style. And the list of possible text props types are defined in fwkernel tlb.idl in the liblcm library. This list is included in the document form of this presentation, but it's too big to put into this display. Time properties store a date and a time and are represented as in this format. Val, they have the 4-digit year, then month, then date with hyphens, and then the time with colons, and then a period for milliseconds. And they should always be in that format regardless of the locale. If you do get dates that are wrong, if you use tools, utilities, write everything, it'll put the dates out in the right format. Each instance of a class has a GUID that identifies that object and is used in linking to other objects. There are two basic types of linking. We have owning links, where most objects are in an ownership hierarchy, normally starting from Lang project. An object can own any number of objects through owning properties, but each object can only have one owner. And then you can have reference links, where any object can reference other objects through reference properties. In both cases, linking properties can be of three cardinalities. We can have atomic, where the link has to be 0 or one object. We can have collections where the links are to any number of objects where the order is unspecified at the conceptual model level. They may be sorted by the program during use. And then we have sequence properties, so it links any number of objects where the order is significant as stored. So those are the different kinds of linking we have. Most objects in Flex are owned by other objects that eventually lead to Lang project at the top level of the ownership hierarchy. For example, Lang project has a parts of speech property that owns a CM possibility list object, and the CM possibility list has a possibilities property that owns a part of speech object, and or a subclass of CM possibility, or that is a subclass of CM possibility. These classes do not have owners. Lang project, Lex entry, punctuation form, SCR-ref system, text, virtual ordering, and Whoopi Ward form. And then CM picture and CM possibility list may or may not have owners. Ownership links always involve two links, one from the owner to the owned object, and then the other from the owned object back to the owner. The owning class has an owning property that holds an obj-sur or object surrogate element with a T type set to O, specifying owning relationship. The owned object has an owner good attribute in the RT header that holds the good of the owning class. To find an object in FW data, the way you can do that is you can look for double quote space good hyphen or equals double quote and then some of the good, the first part of the good, and that'll get you to the real instance instead of some other use of that. Looking at an example from the discussion, owning property in a CM possibility that owns an ST text object, which in turn has a paragraph's owning property that owns one or more ST-text para objects, and then the actual text of the paragraph is in the ST-text para object. In this case, the ST-text para does not have a contents property, so it doesn't have any actual text. So here we have the CM possibility that has this good, and it has a discussion that has this good, and so the discussion now is an ST text, which has this matching good here, and then it has an owner good that refers back up to the CM possibility list. And then the ST text has a paragraphs element with going to this good, and that represents this ST text para object. And again, it has an owner good that refers back to this way. So you can always trace up and down ownership hierarchies to find all the objects that are part of the top element. Reference properties provide links to other objects without involving ownership hierarchy. Reference links are one way in the model. Reference properties are similar to owning properties in that they both use obj-sur elements. The difference is that the reference properties use the T attribute set to R for reference. The following example demonstrates how senses reference semantic domains through a semantic domains reference collection property. So here we have a sense, and it has a semantic domains property, and it has two references, one to this good here, and since it has a T equals R, we know that this is a reference and not owning. And so this reference here points down to this object here, which has a CM semantic domain object, and the owner good doesn't matter because it's owned some other place, so it's not relevant in this case. And then we have the separate good here for the other object, which refers to this CM semantic domain for house. Unlike an owning property, there's no corresponding link from the CM semantic domain back to the lex sense that references it. A reference link is a one-way link. If you want to find all the senses that reference a particular CM semantic domain, you would need to search all semantic domains elements on senses, looking for ones that have an obj-sur with a matching GUID. In code, we have a CM semantic domain has a referring senses virtual method that will give you this information. And there are a lot of virtual methods that will give you a kind of information you'll probably need to go the other direction. In the FW data file, to remove a reference link, just remove the obj-sur element. And if it's the only link in the property, it's best to go ahead and remove the reference property element as well, like semantic domains. You could leave it there, but it's of no use. Styles, default paragraph and character styles are available in all projects. The master list is in C program files, SIL Fieldworks 9, Language Explorer, FLExTools.xml, but this is mainly used for upgrading styles when changes are needed. Users can add new styles as needed or modify existing styles, but built-in styles cannot be deleted in the UI. Styles are hierarchical, so styles based on another style inherit styles or properties from higher in the hierarchy. And paragraph styles are used in dictionary configuration for formatting elements that are treated as paragraph, which include entries and some other elements such as senses and examples, depending on how you format your entry. Character styles can be embedded in strings. Styles are stored in the styles owning property of Lang project and the ST style classes. This shows some of the elements in ST style based on is used for hierarchy. The name is Unicode, so it is not localizable and is the name that is used in strings in the named style attributes. And type is 0 for paragraph and 1 for character styles. And you can see the properties in there. Rather than letting users type and mistype fixed lists, Flex stores many lists to allow users to choose options in various areas, including parts of speech, morpheme types, semantic domains, people, locations, types for complex forms and minor entries, lexical relations, etc. Names and abbreviations of lists and list items are multi-Unicode. Both also have a multi-string description among various other properties. The class for these lists is CM possibility list, and items in the list can be flat or hierarchical. A user can modify some of the properties of a list in the lists area by going to Tools, Configure List. Users can also create custom lists for special purposes. List properties include sorting, whether hierarchy is wanted, and if so, how many levels the writing system's used for display, whether duplicates are allowed, the class item of items to include in the list, etc. And the base class for the list items is CM possibility. There are 13 subclasses that provide extra properties as needed. Lists are used in various classes through reference relationships, which may allow a single reference or multiple references to GUIDs of a CM possibility. So here's some key properties for a basic list with 2 nested items. We have the CM possibility list right here with this GUID, and it has a class of item class ID. I'll mention that in the next slide. And it also has a WS selector, but then it has possibilities. Well, it has a name, the genres list, and it has a possibility or one or more. And this would be one possibility, and it's an owning relationship. And so that would refer over to this CM possibility here that is called monologue. And then, of course, since it's owning, it has a reference back up to here. And then this possibility has sub-possibilities. And this would be a reference here to that, which is also owning, and goes to this one here called narrative. And it again has a reference back up to the owning GUID. So these two purple elements are explained here. The item class ID gives the class ID for the items that can be included in this list. 7 in this case is the class ID for CM possibilities, so this list can only hold CM possibility objects. There are other ones that are available. WS selector selects the writing systems to use when displaying list items for this list. And the possibilities for this property are -1, which would be the first analysis writing system, -2 for the first vernacular writing system, -3 for all checked analysis writing systems, -4 all checked vernacular writing systems, -5 all checked analysis, then all checked vernacular writing systems, and -6 all checked vernacular, then all checked analysis writing systems. So I mentioned we had 13 subclasses of CM possibility, mostly to provide additional properties for certain classes. And these are the subclasses with their class IDs. We have check term, which is no longer used. That was part of translation editor. CM annotation defin is an internal type of list or type. CM anthro item are for the anthropology categories list. CM custom items are if you create a custom list. CM location is in the locations list. CM person is a people list. CM semantic domain has a semantic domain list. Lex entry type is in the entry type list. Lex entry and flexional type is also in the entry type list. Lex reference type is in lexical relations list. Morph type is in the morpheme types list. Part of speech is in grammatical categories list, and PH phone rule feet. It's actually a phonological rule feature list, but it's in grammar, but it's created dynamically based on exception features and inflection classes. And I'll show a diagram of this later on. There are some lists that are used internally in the program and do not show up in the lists area of Flex. All lists, including the internal ones, can be exported using file export all lists XML. This produces one XML file containing all 36 lists, including the internally used lists and custom lists. And the export includes common fields, including GUIDs and class IDs, and there are instructions provided for exporting, or in the export dialog, to convert this file into an HTML file for easy viewing in a browser. And then 3 lists listed in the lists area are unique, reversal index entries or categories. There's actually a reversal index for every, there's a different reversal index for every part, or there's a different part of speech list for each reversal index. And this in the tool here, in the lists area, it allows you to pick one of the reversals, and then it will show you the parts of speech list for that reversal. And then there's a feature types list, which is not really a CM possibility list. Instead, it's a list of FS feature structure type objects owned in the types property of the FS feature system. It's mainly used in, well, it's used in the grammar area, but it's showing in the normal list area. And then lexical relations. This list defines cross-references in lexical relations, and it holds data for these relations. So that's kind of a specialty. Oops, wrong way. These are all of the possibility lists that come with the project, and it shows the owning object and the owning property. and then the name that gets displayed to the user. So if you ever need that information, this is a list that shows all of that. Custom fields. Flex allows users to create custom fields and tools. Configure custom fields for the following classes: FLExEntry, FLExSense, FLExExample sentence, MoForm used an allomorph index on LexDB, shown in the allomorphs section of an entry, segment in interlinear text, and RN generic rec in data notebook. When a user deletes a custom field, all the data will also be deleted. When custom fields are defined, an additional fields element is added to the Lang project element of FW data, if not already there, and additional fields holds custom field elements, each one defining a custom field defined by the user that is unique to this project. Here are some possibilities. I won't go over all of those right now, but you can look at it later and see them. So the possible attributes of the custom field element are name, that stores the original user-defined name of the custom field. A custom name is not allowed if there is already a built-in or custom field that with that same name. If a user modifies a custom field, the new name gets put in the label and it's shown to the user, but the data itself in the FW data file still uses the original name. And then the class specifies the class name to which the custom field applies. Desc class is optional. It specifies the class number of the object owned or referenced by this field. WS selector is optional, and it's a number that determines the default writing system, uses basically the same things I already mentioned. List root for reference properties. This holds the GUID of the CM possibility list, including custom lists that owns the items that can be held in this reference property. There's a help string that's optional that you can just put up that tells what this string is for or custom field is for. And then there's a type that specifies the kind of field. And these are the options currently supported in the UI. You can have a string that's a single line text, first analysis or vernacular. This field stores a string allowing embedding. It actually stores multi-string, but the UI limits it to one writing system. There's a multi-Unicode type. That's a single line text, all analysis and all vernacular. And this field stores a multi-Unicode with no embedding. There's an OA, multi-paragraph text. This field stores an owning atomic ST text that allows multiple paragraphs. It works well for data notebook, but should probably not be used in lexicon because we can't provide the styles in that environment. But you can use Shift Enter in a lexicon to kind of emulate a new paragraph. Then it can be a gen date. Field holds a generic date stored as an integer. It can be RC, that's a list reference for multiple items. This field holds a reference collection to multiple list items. And then RA is a list reference single item that holds an atomic reference to a single list item. And then integer, which is a number. The following examples show how data is stored in custom fields. The name attribute matches the name attribute of the custom field, not the label that the user sees in the UI. This is an example of a custom single line text field set to first analysis or first vernacular writing system. The underlying type is a multi-string field, although the UI does not enable more than one writing system. The string itself can have embedded information. So it's very similar to a multi-string where it has an aster and then one or more runs. And then this is an example of a custom single line text field set to all writing systems. The underlying type is a multi-Unicode field, so it cannot have embedded information. The UI follows normal writing system rules for multi-Unicode, so it has the custom name and then A unis for each of the strings in the field. Here's an example of a multi-paragraph custom field. This is always an owning atomic property that holds one ST text. This example only shows the ST text good. The rest of the objects would be defined as normal RT elements. And then here we have an example of a list reference, multiple items. The underlying type is a reference collection field, which holds references to objects. The single item type would be the same, except the UI only allows it to hold one item. So this would have obscure elements with a T for R for reference. This is an example of a date custom field. The underlying type is a gen date. And so that's there. And then this is an example of a number custom field. The underlying type would be an integer. Send receive data. We're not really talking about that here. Send receive here, but I did want to share just a little bit about the data. It allows users to collaborate in a single Flex project for full information. See this link here. Although designed for send receive, the format used in send receive may prove more useful than FW data for certain purposes. It's always possible to do a send receive to USB to provide the send receive format, even if you're not normally using send receive to collaborate with others. With appropriate mercurial commands, it's possible to make changes to the files and then load those changes into your Flex project. This is one way to import a possibility list. And section 4.8 in the above linked file talks about this. Before sending to a repository, the FW data file is split into numerous files based on domains. This is done to reduce the size of files that need to be merged and to provide appropriate merge logic for different kinds of files. In general, the format of the split files is similar to FW data. However, the significant difference is that instead of each object being a separate RT record, as in FW data, the files are based on certain objects and own objects within those objects. So the FW data file gets split into these: directory and anthropology, a general lexicon, linguistics, discourse, inventory, lexicon, morphology, phrenology, and reversals. And the inventory is the word list inventory, and that's actually split into 10 individual files, and the lexicon is also split into 10 individual files. So here's a simple entry in Flex with an example sentence and a translation. The next slide shows how this entry would be stored in FW data with some extra fields removed. The RT objects are sorted by GUID. So this is the order they would occur, with many other classes mixed in between these classes. For links to possibilities, I've just added the string in curly braces rather than adding the actual possibility classes. And I've also highlighted in green the actual text that appears in the entry display. Now, I don't expect you to be able to read that. It's readable if you go to the document. But basically, you see that we have several different objects that are all scattered across the FW data file that hold the data that we're interested in. The next slide shows the same sample in a LexDB file used in the send receive. In this format, all of the owned objects for the entry and sense are included inside the owned objects rather than scattered around in FW data. And thus the owner GUID is not needed. And it's also indented to see the hierarchy. Deleting an entry is much easier because you just need to delete everything between Lex entry and the closing bracket or element. And so here again, you can't read it, but you can see the hierarchy there, and it's all inside of one Lex entry element rather than splitting all the pieces up. So this is a possibility if it's useful to anyone other than for send receive. And I should mention too, there's a lift format that's described in this link here. And Flex can import and export dictionaries in lift format, which is a much simpler format. And in some cases that's useful. In other cases, you can run into trouble because the lift file does not have all the information that Flex has, and you can run into trouble when you try to import in certain cases. Okay, I wanted to go over conceptual model resources, things that can help you understand the model. And there are various tools and resources that can help with understanding the model and data. One way to see how something is modeled in Flex is search the FW data file to see what is in the file for a particular object. You could type some unique string in the area you're interested in and then search for that in the FW data and then follow what happens in FW data. For an entry, you can control right-click the entry in the dictionary or dictionary preview and choose Inspect Entry. This opens a window with the entry GUID at the top and the XHTML data in the bottom. So that's one way to get a GUID for an entry. In FLExTools utilities, find and fix errors in a Fieldworks data XML will remove any links to non-existent objects. It will also delete objects that are missing owners. This can correct occasional problems that occur within the program, but it's also useful for manual editing the FW data file. If you delete a Lex entry RT object and then run this utility, it will remove all of the ownership links, delete all objects that were owned by the entry, and remove all references to any of the deleted objects. And the write everything utility will rewrite the current project FW data in the standard way, which will clean up manual changes that may be missing some null properties or improperly formatted dates. ZEdit is a simple editor that is installed in the Fieldworks program directory. It memory maps the data when a file is opened, so it can open large FW data files very quickly and can be used to make changes. But just be sure to close the FW data file before trying to do anything in Flex that tries to update FW data, since ZEdit blocks the file from being written. Notepad++ takes a lot longer to open a file, but it can remain open while Flex is being used. And one of its main advantages is supporting regex that can be very useful. And again, if you're looking for the object itself, you can look for double quote space GUID equals double quote and then part of the GUID or the whole GUID if you want. Model diagram. There's a useful model diagram. You can download it from this link here. If you're using Windows 10 or 11, the file will be blocked by Windows after a download. To enable it, right-click the downloaded file and choose Properties, then check the Unblock box. This was constructed by hand, so there may be some errors or missing things. And unfortunately, the program that was used to develop this disappeared many years ago, so we haven't been able to keep it up to date with the latest changes. However, for the most part, it is still accurate and helpful. Interlinear text is not correct anymore, and directional links for reversal indexes are wrong, and some newer things are missing. It also has all of the classes for scripture used for translation editor, which no longer exists. And basic scripture classes are still used when loading data from paratext, but most of the other classes are unused. The CHM file has a diagrams link in the upper left pane that lists 25 diagrams of different areas of the model. So I'd like to switch over to that program. Let's see. Okay, this is the file now. And it has a classes interface here that lists all of the classes in Fieldworks. Have a bunch of them. If we take a look at FLExTools, we have a showed all docs thing that shows all the documentation for that class and the properties and hide. And then you can also click this to open up the documentation for a single element. Then the class itself, we have the class name, and then there's a number, an abbreviation. The abbreviations are no longer used. And abstract is false or true. Most of them are false. And then there's a module number, and then there's a base class. Now the actual class number at this point is based on the module number followed by a 3-digit number here. So the class ID for FLExEntry is actually 5002. And then for the properties, there's a number here, but the actual FLID or field ID consists of the module, the class ID plus a 3-digit number here. So for this particular class, it would be 5002012. And so this shows all the basic attributes for FLExEntry, the name of the class or the field, and then the signature, what it holds. And then if you go down here, it shows all of the owning and reference attributes, the types, it says referring or owning. And then you have the class name and then the number again. The cardinality, it's a sequence or atomic or collection. And then the signature of the object. And then down at the bottom, back references no longer applies. This was all done back when we were using the SQL Server, so it's part of it's out of date now. Okay, then if we switch over to the diagrams, let's go to the lexical database diagram. Okay, now we have rectangles for each class, and inside the rectangle we have the basic properties for that class, and then reference and owning classes or properties are lines between squares or the rectangles. When we have a property like this, a link with an open arrow, that means it's an owner, a class hierarchy. So LexDB is a subclass of CM major object. And then for owning attributes, it has this little diamond with the name of the property. And then at the other end, we have either 0 ... asterisk, which means it can have 0 or more entries, or for an atomic attribute, it just has a 1 there. And then for reference attributes, it's a line with a name, but it doesn't have the diamond on it. And so this shows the FLExEntry here with all of the things that it has in it, and then FLExSense and all of the things that are in the FLExSense. So it's helpful. This diagram lets you kind of get the overall view of how things are. And I think that's okay. I just wanted to take a quick look here. There's a lot of complexity built into Flex. This is the morphology model. You can see there's a lot of stuff here in morphology. So there's a lot to learn or a lot to use. And then I wanted to go up to CM possibility. So this now is the CM possibility list, and this is the CM possibility. And these are all of the subclasses of CM possibility that show the different attributes or properties for the different subclasses. So that's basically what I wanted to show here. So let me stop that and get back to our presentation. Okay, we have a spreadsheet that's up to date with the model, since that diagram is out of date in some areas. When we build our source data, our source code, we have a single file called master lc model.xml that has all of the current master, all the classes and information regarding those classes. And it's located in the liblcm sil.lc model/source directory, but you can get to this directly from GitHub by going to this link if you're interested in seeing that or using it for anything. And there's also an XSD file that defines the structure for that file. But the information for this model file has been put into a spreadsheet that can be downloaded from this other link here. And the spreadsheet is one way that you can find accurate information for all classes and fields. It has two tabs, one for classes and the other for fields. The labels along the top all have drop-down menus that let you sort on that column, or you can use normal data tab sort and filter options in Excel for getting more complex filters. The classes tab has these columns, class ID. All of these columns basically come from that XSL file. Class ID is the class ID. It comes from the module and class number. The class is the name of the class. The base is the base class in the ownership, the class hierarchy. Depth is how far it is from CM object. Abstract, true, it means the class cannot occur in data. Only subclasses can exist. False means that the class can occur in data. Abbreviation is no longer used. Singleton means that the database can only have one of these objects in it. Owner, none means there is never an owner for this class in the ownership hierarchy. Optional means there may or may not be an owner. And anything that doesn't, that's missing something always has an owner. And then there's a gen create, that when false, this class can't be created in code with a create method without any parameters. And that's basically for programmers, but that can be useful when you get into FLExBridge or FLExTools. And then comment is a documentation for the class. Then for the Fields tab, we have a FLID, or the field ID, which includes the module and class numbers. The class, which is the name, field, the field name, type, the type of field, basic, owning, or reference relation, cardinality, owning, atomic, collection, or owning and reference, atomic, collection for collection, and sequence for sequence. And then a signature of what goes into that property. Basic type is binary, Boolean, various other ones. Owning and reference types, the class name of the object in this property. When a class is listed here, any subclass in the class hierarchy is valid for this property. Big is in the model, but it's no longer used. Min and max are for integer values, properties, and give you the minimum or maximum values that we allow for that integer property. And then a comment. And with this spreadsheet, you can find answers to quite a few questions. Rather than reading that, I'm going to just go ahead and jump over to the spreadsheet now and let you get a feel for that. Okay, so here we have the two tabs. See what's going on here. Oh, okay. Classes and fields. So classes, we have the class ID and the class number, the base, depth, and all of the different things that we talked about. And the documentation, if you click on any one of these, it'll tell you something about the field. May or may not be useful, but at least it's some information. And if we wanted to do something here, if we sort on class, no, owner, let's sort on owner. Okay, that brings together all these that say none. So these classes here are ones that never have an owner in the FW data file or in the project. And then there are two optional ones. So that's one way it can be useful. If we go to base class and sort on that, and then we go down to CM possibility. Okay, so these are the sub possibilities or the subclasses of the CM possibility. And you have the class numbers for all of those. If we jump over to the fields tab, now we have the FLID for the field. We have the class that the field that owns the field, and then we have the field name and various properties that we mentioned before. And in this one, if we want to, let's sort on class. And let's go down to Flex entry. There we go. So these lists all of the fields then for Lex entry and the property information on each field. Or if we go to signature, let's see here, we go to signature and sort on that one. And then we go to CM possibility list. Okay, so that's these here. And all of those now, these are all of the places that own or reference a CM possibility list, and it shows you where they're from. So this can be quite useful because it is up to date, and you can find out a lot of information. And it's probably easier to find it here than trying to go to the actual XML file and using that. So I'm going to stop sharing that now and jump back over to our PowerPoint and go to the next. There's an LCM browser program that gets built with Flex and is installed in the program directory. LCM is an abbreviation for SIL Language and Culture Model. An LCM browser is a program that comes with Fieldworks and can be started by typing into the Windows Start menu or finding it in C program files, SIL Fieldworks 9. LCM browser has a LCM model tab for showing the current conceptual model. It has a browser, or can open up an FW data file, and then it lets you browse the data and make limited modifications, like you can delete an object. Once open, there are two more tabs, a Lang project tag and a repositories tab. And then LCM browser will not open a project that is open in Flex and vice versa. Changes are saved automatically as in Flex. The only search capability is for a GUID, which opens a new window for that object. So now I'll switch over and demonstrate that tool. And I have a project open already in this, so it has 3 tabs here at the moment. But this one here will open up even without a project open. And what this shows is, and again, this is current, it has all of the current information. It starts at CM object and then shows all of the objects that are subclasses of CM object. One of the problems with this is if you're looking for something, let's say I want to find FLExDB, but I come down here to the Lex and it's not there. And that's because it's a subclass of some other class. And so unless you know where to look, it's hard to use it. But here I know that FLExDB is a subclass of CM major objects. And so here's the FLExDB right here. Then I want to drop down to Lex entry. Okay, now in this tool, it's showing all of the properties, well, almost all of them. It has the implementers. So since Lex entry is a subclass of CM object, it means all of the CM object methods are also available. And so we have good and own, ord, and other things. And then these are all the fields that are implemented on Lex entry itself. And then the type of the field and the signature of the field are all here. If we, one of the best features in this program is you can come up here to the view and say, display virtual properties. And so now you can see all the virtual properties that are available on Lex entry as well as the actual properties. So now we can see an owning property or owner property, this one here, that's a virtual attribute. And also, if we go down to, what's another one? Okay, Mo. Well, all of these, all sub-entries is virtual. So we have a whole bunch of virtual properties. And so it's useful having that kind of information that we don't get from any of the other sources. I'm going to turn that off for a bit. There's this class properties here that just lets you pick a class and decide which fields you want to show. And for that, I've never actually used that one. Then if we switch over to, we have a database loaded. And we have 2 tabs here, the Lang project one and the repositories. So if we go to the repositories, what it's showing here is it has 1 line for each class, and Flex maintains repositories for each class. And so this shows us that for analysis repository, it has 631 of these. Let's drop down here to the this one here. This is CManthro item repository. And this number here is the number of items that we have in the database for that of this type. And if you open that up, then it gives you a list of all of them. And if you open up one here, now you're seeing the actual properties for this class. And then you can see it has the GUID and all the other things. And this shows you the type of the field. So you can get a lot of information this way, but it gets a little bit challenging finding it at times. Then the other way of looking at things is to go to the LangProj tab. And what this does is it starts at Lang project and then has all of the things that are owned by the Lang project. And then if we want to, let me drop down to, notice here, we don't have any entries field for entries in the, oh, I wanted to go to Lex database. That's what I want to do. Okay, open up Lex database. Okay, here we have this, but now we don't have any entry field here. And so because all the entries do not have an owner, so we have to have a virtual property. So if I come up here and put virtual back on again, now under entries, we'll have an entries that shows we have 24 entries in this project. And if we open that up, the numbers that it's showing in here are the HVOs. And if you open up one, I'm going to open up number 15. Okay, this is the Mise-en entry. And now we can, so it's this good, 8465, I mean HVO. And we have all the different things that are possible in here. If we go to senses, OS, then we open this up and there's only one sense here. We can open that up and we can see the definition, and we can go in a virtual thing. We can, this is getting a little ahead of ourselves because I haven't explained all this model yet. That comes on Thursday. But for lexical relations, this here shows that we have several lexical relations, and you can continue to move on down. So you can work your way through the project using this, and it can be fairly useful at times. Then there's one other thing I wanted to show. Okay, if you know the GUID of an object, then you can come up here in the search thing. Why is that not working? Oh, there. Okay. And so what it does is it opens up a new tab now with the Lex entry. That's what I wanted to show with this, and get back here to finish up the project. There. Okay, if you're interested, the source code is all available to you. This is an open source program. It's on GitHub, and this shows the, you can download the sources. The program sources are in this URL here. The following repositories are needed for a Fieldworks code. There's a Fieldworks repo that's for the basic Fieldworks code. There's a chorus one for send receive. It's a liblcm. That's the basic Fieldworks model code. And if you're using FLExTools, this is basically what you're dealing with. And then there's a libpalazzo library with other types of things that Flex uses, and then FlexBridge for send receive. To get the source code using git bash, you can use this command, and you can pick up any one of the codes and then download it to your machine. Fieldworks can be built on Windows using the free Visual Studio Community Edition. For more information about building Fieldworks, there's a URL here for doing that. And debugging, if you're interested, there's a dnspy debugger that's available that you don't have to install. You just download it, and then you run it from, and you unzip the file, and then you run it from a file inside the zip file. And these are the instructions that let you actually start Fieldworks in the debugger and start to use it. So that's can be useful at times.